have given, but unfortunately nobody has done this. Already I have given you that hint, okay? And this question is really interesting. So if you remember, there is a cylindrical cross section, right? And that cross section is basically divided by two equal parts, right? The lower portion was filled with water, right? And the refractive index of water was given, that is 1.33. Okay. Upper portion was filled with what? Gas. The refractive index of gas actually you have to calculate. Okay. There is a laser source on the lowest point of the cylinder. Okay. And this source can move on the surface of this cylinder. Also, the diameter of this cylinder was given, right? D was how much? 2.2 meter, right? This laser source can move on the surface of the cylinder, and the beam from this laser actually pointing where? At the center of the laser, center of this cylinder, right? And it is given that when the source is away from this distance, S equals to how much? 1.09 meter. Then what is happening? Whatever ray is striking this center, that refracting ray cannot enter to the gas. I mean, when S less than 1.09 meter in this region, when that ray is striking that center, the refracting ray can enter to the gas. But when S is greater than equals to 1.09 meter, then what is happening? That whatever ray is striking at the center, it cannot enter to the gas. It means basically the theta corresponding to this distance, that is actually your critical angle. So the question was, you have to calculate first this Ng, refractive index of gas, okay, as well as critical angle you have to calculate. Then third thing, when S is greater than 1.09 meter, then the whatever ray is striking at the center, it will come to the surface, right? So how much time it will take to reach that surface? Refracting ray reach that surface, that you have to calculate when S is greater than 1.09 meter. Also, there's another question, when S is smaller than 1.09 meter, then how much time that refracted ray will take to reach that surface? Whatever ray is striking to the center, how much time it will take to reach that surface? Okay, so these things I have done already, right? I think we are doing this part. So critical angle is actually how much, Anju? We have derived, right?
Sir, 55.7.
Actually, there is a little correction. If you calculate this critical angle, you will basically get not 55.77, but it is actually 56.77 degree. So there is a small typo was there. Okay. Okay. Then we can calculate that refractive index, right, of Ng. So by using that concept of critical angle, sin theta c, that should be equal to how much? Ng by Nw, right? From the concept of critical angle. So from here I can calculate that refractive index of gas, that should be equal to Nw into sine of theta c. Now Nw is given here. If you substitute this value, and theta c we have calculated, if you substitute here, then we'll get that refractive index of gas, that should be equal to 1.1. It's very simple calculation. Now we see. Now when S is greater than 1.09 meter, then what will happen, Shekhar? Whatever ray is striking, when S is greater than 1.09 meter, in this situation, what will happen? जब आपका एज ग्रेटर देन 1.09 मीटर हो रहा है तो वॉट एवर रे इज स्ट्राइकिंग the angle of incident is actually theta, that is greater than theta c. So in that situation, what will happen? There will be total internal reflections. Whatever ray will strike there, it cannot enter to the gas, but actually it will again come back to the water. Okay, so you have to keep in mind, when the angle of incident is greater than the critical angle, then what will happen? There will be total internal reflection, right? So it means that light cannot enter to another medium. Okay, so there will not be any refraction when theta greater than theta c. So in that situation, how much time? So we know time taken is nothing but distance divided by velocity, right? So how much distance is traveling when this situation? S is greater than 0.9 मीटर. तो कितना डिस्टेंस ट्रेवल कर रहा है? यहाँ से सेंटर तक कितना है? That is radius, right? यहाँ से सेंटर, right? That is actually the radius of this cylinder. Then यहाँ से फिर water में जा रहा है surface तक. तो ये distance R and this is R. So total distance traveled is actually how much? 2 into R. And R we can calculate from the diameter. That will be how much? R will be 1.1 meter. Now you have to take that velocity of light. So since that light is only traveling through water, so what I'll do, I'll take the velocity of light in water, right? So from here I can calculate 2 into R is how much? 1.1 meter divided by V. VW will be how much? It will be nothing but C speed of light in vacuum 3 into 10 to the power 8 and divide by refractive index of water. So that divide actually go to where? Numerator, and that NW is actually how much? That is 1.33. Okay. Is this clear to all what I'm saying? So if you calculate this value, the total time taken will be 8.94 nanosecond. Now, Karthik, can you please tell me what will happen in this situation when S is smaller than 1.09 meter? मतलब जब आपका लेजर सोर्स लोएस्ट पॉइंट से S equals to 1.09 मीटर इस बीच में है, then whatever ray is actually striking at the center, right, that ray can enter to the gas. So there will be the phenomena of refraction, right? There will be the phenomena of refraction. So, and also you have to keep in mind that theta, angle of incident, will be different from angle of refraction, since mediums are different. Okay, but actually what is happening when this phenomenon at this situation, S is smaller than 1.09 meter, at this situation actually angle of incident will be smaller than critical angle. So at this situation there will be the phenomena of refraction, right? So half of the path will be traveled through water and half of the path will travel through gas, right? So what I can write, the total time taken by this light, that will be nothing but this distance, so that is R, distance traveled divided by velocity of light in water, right, plus this distance, again it will be R, and that velocity of light in gas. So this can further I can write in terms of C and refractive index. Okay, just what you have to do, in place of VW you have to write C by NW, and in place of VG what you have to write, C by NG, right? And we know that value of R. So in that situation, you have to calculate this value. Okay, so this I have written how much? This I have written 8.94, right? Actually you will get, this is sorry, this is actually 9.75 nanosecond. And if you do this calculation when S is smaller than 1.09 meter, so in that scenario, total time taken will be how much? That will be 8.94 nanoseconds. So just substitute that values. Okay, it's a very simple calculation. Is this clear what I'm saying?
Sir, So यहाँ time taken to reach the surface of water पूछा ना, तो सेकेंड केस में हम गैस तक पहुंचे, वहां से रिफ्रैक्ट होके वाटर तक आना है ना?
हाँ नहीं 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 नहीं, रीच द सरफेस। दो सिचुएशन है, एक तो आपका ये सिचुएशन है जब आपका एस ग्रेटर देन 1.09 मीटर, तो कहाँ से, मतलब जहां से जर्नी शुरू हुआ है लाइट का, वहां से सरफेस में रीच करने के लिए कितना टाइम लगेगा, ठीक है। अब जब आपका एस ग्रेटर देन 1.09 मीटर है, तब क्या हो सकता है, तब क्या होगा, that is the situation that angle of incident is greater than critical angle, because critical angle corresponds to s equals to 1.09 meter. So when s will be greater than 1.09 meter, then angle of incident is actually greater than critical angle. So in that scenario, there will be the phenomena of total internal reflection. So whatever ray will strike at the center, it will again come back to the surface with the same medium. Okay. So total distance will be how much? This distance plus this distance. That will be nothing but
सर,
twice of r.
तो सेकेंड केस बोला सर,
हाँ सेकंड केस के लिए
सरफेस
आप
ऑफ
देखो,
वाटर है ना?
हाँ सेकंड केस के लिए देखो, जब आपका सोर्स कहाँ से कहाँ किस बीच में है, फ्रॉम बॉटम टू s इक्वल्स टू 1.09 मीटर। इन दैट सिचुएशन क्या है आपका, जो एंगल ऑफ इंसिडेंट है दैट इज स्मॉलर देन द क्रिटिकल एंगल। तो जब आपका एंगल ऑफ इंसिडेंस स्मॉलर देन क्रिटिकल एंगल होते हैं अंजू, तब आप बताओ कौन सा फेनोमेना होगा, यहाँ पे टोटल इंटरनल रिफ्लेक्शन होगा या रिफ्रैक्शन होगा?
Fractions.
Exactly. So if there is a refraction, then what will happen? That light will come from that surface to the center. Then what will happen? It will reach to the another medium, and that is nothing but gas. So actually, half of the path will be traveled through water, and half of the path will travel through gas. And you know half of the path means, half of the path means nothing but the radius of this cylinder. So that's why I have to divide into two components. Half of the path will be traveled through water divided by velocity of light in water, plus half of the path travel through gas divided by velocity of light in gas. And I'm sure that you can calculate these values because this is nothing but C by N, right? And we know that N for both medium. Is this clear, Anju, what I'm saying?
सर
Now-
क्वेश्चन में टाइम टेकन टू कम बैक टू द सरफेस ऑफ वाटर है ना?
No, no,
तो
no.
हम
No, देखो ये दोनों सिचुएशन आपको गिवन था, राइट? ये दोनों सिचुएशन में टाइम टेकन बाय एक्चुअली कम बैक टू द वाटर सरफेस नहीं था, टाइम टेकन बाय लाइट टू रीच द सरफेस ऑफ द सिलेंडर।
ओके सर।
इस केस में क्या होगा आपका, इस केस में आपका वाटर सरफेस में आएगा, जब आपका एस स्मॉलर देन 1.09 मीटर है, इस केस में क्या होगा आपका, दैट विल बी एक्चुअली द गैस सरफेस। इज दिस क्लियर नाउ?
ओके सर, यस सर।
So this was actually MSQ question, but this question was really interesting. Okay, so we have this. Now we'll discuss about angle of deviation. Discuss about angle of deviation, and that is basically represented as delta. Okay. Now we know from the suppose this is the plane surface, and this side, upper side, you have a medium 1. Okay, and lower side you have a medium 2. Okay, and suppose this is the normal on the surface. This is the normal on the surface. A ray is incident at an angle of I. Then what will happen? It can reflect also, right? It can reflect also with same angle as angle of incident. So this will be I. So I can write this angle as well as I. Now, if the path is undeviated, then how can I show that? I can show like gas line. अगर यहाँ आपका रिफ्लेक्शन नहीं होते, so that light will follow this path, undeviated path, right? So angle of deviation is nothing but, क्या angle of deviation होगा? actual path minus, or you can say that angle of deviation is nothing but the angle between actual path and deviated path. इनके बीच में ये आपका actual path था, undeviated path, but actually light followed this path. So this angle, this will be the angle of deviation. Did you get what I'm saying? So it was traveling like this. So if that light was it is actually undeviated, then it will follow a straight line, but it is reflected. Okay, so basically it is deviated from its original path. So how can I calculate or note that angle of deviation? So this angle between undeviated path and path followed by this ray, this angle will be the angle of deviation. So how much it will be actually? Anju, can you please tell me? So Anju or Kartik, anyone, Shekhar? So I know this angle. So total angle is how much? Can I show like this? So this angle will be how much total, Kartik? यहाँ से यहाँ कितना एंगल होगा आपको बताओ?
135. 180 degrees, sir.
Exactly, it will be 180. So can I write 180 equals to I plus delta, right? Because this 180 is basically sum of this angle plus this angle plus this angle, right? So I can write I plus how much? Delta. So from here I can calculate that angle of deviation, and that is nothing but 180 degree minus twice of I. Okay. So if I know that angle of incident, then our job is very simple to calculate that angle of deviation. So angle of deviation is nothing but 180 degree minus twice of angle of incident. So wherever you have to calculate that angle of deviation, so before doing that, you have to calculate that angle of incident. If you know that angle of incident, then you can easily calculate that angle of deviation. Now let us solve a good question based on this. Okay. Suppose you have a two plane mirror, M1 and M2. The angle between them is theta. Okay. The angle between them is actually theta. Okay. And a ray is incident. A ray is incident on mirror M2 at an angle of I. So this is the incident ray. So after that it is reflected. After that it is reflected like this, and it is strike or it is incident on mirror M1. So after incident on M1, again it is reflected like this. Okay. So this is the actually emerging ray, and this is actually your incident ray. So you have to calculate the angle of deviation of this ray. How much it will be actually? How will calculate that? So we know that angle of incident, that is they have given you, that is I. So a ray is incident on mirror M2 at an angle of I, then it is reflected, again it is incident on M1, and then it is going like this. Okay. An angle between M1 and M2, that is given theta. So you have to calculate the angle of deviation. So before going this, doing the total, before calculating the total angle of deviation, you have to calculate angle of deviation here. कितना आ जाएगा यहाँ angle of deviation बताओ? How much it will be? ये आपका रे आपका इस तरह से जा रहा था, then it is reflected like this. So the original path can be shown like this, right? So this much will be the angle of deviation, है ना? ये आपका original path है और ये आपका path followed है. So the angle between this and this, that will be angle of deviation. And let us give that notation, that is delta 1. Let us give that notation, that is delta 1. So delta 1 will be how much actually? So already I told you, if you know that angle of incident, then I can calculate that angle of deviation. That will be how much? So very simple. I can write 180 minus twice of I. Twice of I, because angle of incident is how much? I, right? Is this clear what I'm saying? And the angle of deviation actually in which direction? It is like this. You see? So this angle of deviation is actually what? This is in clockwise direction, because this is the angle of deviation and direction is like this. Okay. Now if I know this angle, this will be how much? कितना हो जाएगा? This is the angle of reflection, so I can write like I, angle of incident. Now if I know this angle, I can calculate this angle as well. ये कितना आ जाएगा? This is your normal. This angle
90 minus I.
exactly. So this angle, this is the normal. This is the angle of I. So this angle will be nothing but 90 minus I, right? Now how much will be this angle? So this I can calculate. So how total, if I consider this is the triangle, so sum of the angle will be 180. So theta plus 90 minus I, okay, plus, let us give another notation. Any notation you can take. Let us take that notation like theta prime. That should be equal to how much? 180 degree, right? So from here I can calculate this angle. कितना आ जाएगा? Theta prime. It should be 90 plus I minus theta. Now if I make it normal here, because ray is incident here, so if I make a normal, how much will be this angle? कितना आ जाएगा? So total angle is how much? Theta prime plus this angle will be how much? 90. But theta prime is how much? 90 plus I minus theta. So this angle will be how much? Let us give that notation, theta double prime. So theta double prime should be equals to 90 minus theta prime. Am I correct? Theta double prime should be equals to 90 minus theta prime. So now if I substitute that theta prime here, then how much I'll get? 90 minus 90 plus theta minus I. So this 90 will be cancelled and we'll get theta minus I. So whatever ray is reflected from here, it is incident at an angle of how much? Shekhar? Saurabh, कितना angle में incident हो रहा है? Whatever ray is going from this mirror M2, it is incident on M1 at an angle of how much? Theta double prime, and that is nothing but theta minus I. Am I correct? Is this okay what I am saying? Shekhar, Saurabh, Rajkumar?
सर थीटा डबल प्राइम समझ में नहीं आ रहा.
So you should ask me na. So first, did you get how this angle is? कितना आएगा ये angle बताओ? So total angle I plus this angle will be how much? 90. So if this is I, this angle will be how much? 90 minus I. So I have calculated this 90 minus I. Now if I consider this triangle, ये अगर triangle है, this angle is how much? Theta. This is 90 minus I. And let us assume this angle is theta double prime. Sorry, theta prime. So theta prime plus theta plus 90 minus I. This summation will be how much? That will be 180 because it is a triangle, right? From here I can calculate that theta prime. So theta prime will be how much? By simple mathematics, you will get theta prime will be 90 plus I minus theta. Okay. Now this angle I got how much? कितना आ गया आपका? 90 plus I minus theta. Now to calculate that angle of incident on mirror M1, whatever ray is going, it is incident on M1, right? So to calculate that angle of incident, we have to make the normal. मैंने क्या ड्रॉ किया? नॉर्मल किया. अब इस मिरर की सरफेस के ऊपर ये आपका नॉर्मल है, राइट? So angle between the surface and normal will be how much? 90. So what I'm saying, this angle plus this angle should be equal to how much? 90. And this angle I have assumed, how much? Theta prime, and this angle I have assumed how much? Theta double prime. So sum of theta prime plus theta double prime, that should be how much? That should be 90 degree. Okay, it means theta double prime should be equal to how much? 90 minus theta prime. And I have calculated that theta prime. Just I'll substitute here and I'll get theta double prime. That is theta minus I. Okay.
Yes, sir.
Okay. Now here again that ray is actually deviated from its original path. So if it is undeviated, then how it will look like? It will be look like a what? Straight line, right? So it was going like this. So undeviated path will be straight line. Okay. So here again you have a deviation. How much deviation is actually this angle? And let us assume that angle of deviation here, that is delta 2. So how much will be the delta 2? Anyone? So again I'll use this formula. 180 minus
2 minus 2
angle of incident. Angle of incident कितना है? That is theta double prime. It means twice of theta minus I. Okay. Whenever they will ask you to calculate that angle of deviation, what you have to do? You have to calculate that angle of incident. So if you know that angle of incident for reflected ray, angle of deviation will be nothing but 180 minus twice of angle of incident. Now again, can you please tell me in which direction that angle of deviation happens? If you see, it was like this, but it is going like this. Again, it is like a clockwise. Again, it is like a clockwise. So both angle of deviation, this is delta 1 in clockwise, delta 2 again clockwise. They are basically in the same direction. So net angle of deviation will be how much? Since both are in the same direction, so so net angle of deviation, just I'll add them because they are in the same direction.
सर सेम डायरेक्शन एक बार फिर रिपीट करो.
हाँ देखो आपका ये डेल्टा 1 को देखो, डेल्टा 1 अगर अनडेविएटेड होता किस तरह जाता? इस तरह से जाता है ना. डेविएट होकर किधर गया? इधर गया, राइट. तो डेविएशन किधर किस तरफ हुआ? यहाँ इधर जाता बट इधर गया है, तो डेविएशन पाथ इज लाइक दिस. तो इज इट क्लॉकवाइज और एंटी क्लॉकवाइज?
क्लॉकवाइज.
एग्जैक्टली. यहाँ देखो इस केस में इधर जाते जाते आपका रिफ्लेक्ट होकर इधर गया, तो डेविएशन किधर हुआ? अनडेविएटेड पाथ से डेविएटेड. तो किस डायरेक्शन में हो रहा है? आप देखो ये भी क्लॉकवाइज हो रहा है. नहीं,
ये एंटी क्लॉकवाइज होता सर, माइनस लगाते हैं.
हाँ
एंटी क्लॉकवाइज होता तो डेल्टा माइनस डेल्टा 2.
हाँ एंटी क्लॉकवाइज होता तो फिर आपको सब्सट्रैक्ट करना पड़ता है ना. सपोज मान लो, मैं एकदम रियल एग्जांपल दे रहा हूँ. सपोज मान लो डेल्टा 2 आपके पास आ गया 100 डिग्री, हाँ, और एंटी क्लॉकवाइज 100 डिग्री एंटी क्लॉकवाइज, और डेल्टा 1 आपका आ गया 80 डिग्री और आपका क्लॉकवाइज आ गया. तो नेट कितना लिखोगे आप? नेट आप ये लिखोगे 20 डिग्री एंटी क्लॉकवाइज, है ना. नेट विल बी बड़ा माइनस छोटा, और बड़ा का डायरेक्शन आपका लेना पड़ेगा. ठीक है ना.
यस.
डेल टू कैसे लिखे?
हाँ सॉरी,
डेल टू 180 minus 2 थीटा minus I.
हाँ दूसरा जो रे है उसके लिए एंगल ऑफ इंसिडेंट कितना था आपका? डेल 2 के लिए, डेल 2 जो लिखा था, सेकंड जो मिरर M1 में जो रे स्ट्राइक कर रहा है वहां पे एंगल ऑफ इंसिडेंट कितना है आपका? दैट इज एंगल ऑफ इंसिडेंट इज नथिंग बट थीटा डबल प्राइम, राइट शेखर?
यस सर.
हाँ, थीटा डबल प्राइम कितना आया था आपका?
थीटा minus I था.
थीटा
minus
माइनस आई.
I.
ओके, तो थीटा माइनस आई. सो एंगल ऑफ डेविएशन क्या होता है आपका? डेल 2 180 माइनस ट्वाइस ऑफ एंगल ऑफ इंसिडेंट. एंगल ऑफ इंसिडेंट कितना है आपके पास? थीटा माइनस आई है. ठीक है.
Got it.
हाँ ओके. Now this is like from the reflection. Okay, this is whatever we have calculated that angle of deviation, that is because of reflection. Now similar thing, that angle of deviation we can calculate for refracted ray as well. Okay, let us take an example. Okay, suppose you have a spherical medium. Okay, and this medium having refractive index, okay, that is √3. Okay, and let us draw the horizontal line. Suppose this is your horizontal line. Okay, a ray is incident and the outside medium or this spherical medium is surrounded by air. Okay, so outside medium is actually what? Air. the refractive index of air is on, we know, right? And a ray is incident at an angle of 60 degree. Okay, and then it is going like this. It is going like this. Oh, sorry. Suppose this is the center. And this is the angle of emerging. मतलब जो so this is the angle at which this angle E is the angle at which the ray is actually emerging. So again, I am repeating. You have a spherical medium having refractive index √3. This medium is surrounded by air. The refractive index of air we know, that is 1. A ray is incident at an angle of 60 degree and it is going like this. Okay, so you have to calculate this, the angle at which this ray is emerging from spherical medium. This E you have to calculate. Then also you have to calculate that angle of deviation for this case. कितना angle of deviation हुआ है? कैसे calculate करोगे? Okay. So first of all, if this ray is undeviated, then it will follow that straight line that I can show like this. That I can show like this, right? So let us calculate first the angle of refraction. ठीक है ना? तो अगर सपोज मान लो आपका अगर रे अनडेविएटेड होता तो वो एक ये स्ट्रेट लाइन फॉलो करता तो ये एंगल कितना होता आपका? अंजू बताओ. If this ray is incident at an angle of 60 degree, if it is undeviated, then it will follow straight line. Then this angle between horizontal line and that undeviated path, it will be how much?
60 degrees, sir.
Exactly 60 degree. But actually it cannot be 60 degree because of different medium. Now I'll calculate that angle of refraction by using Snell's law. So can I write that NA sine 60, that should be equals to how much? NM into sine of R. Okay, NA is given on and sine 60 is how much? √3 by 2. NM is given √3, so I can calculate that sine of R. So R will be how much? 1 by 2 किसका होता है? Sine 30, right? So it means that angle of refraction will be 30 degree. So this angle is actually how much? 30 degree. तो यहाँ पे कितना डेविएशन हुआ है राजकुमार? कितना डेविएशन हुआ है? तो टोटल was 60 degree. This is the actual, I mean, this is actually actual angle. तो डेविएशन कितना हुआ है? ये वाला पोर्शन आपका डेविएटेड हुआ है. कितना है ये? So let us denote this deviation is delta 1. So delta 1 will be nothing but how much it will be? Total will be 60 degree. Total is 60 degree. This angle is how much? 30 degree. So 30 degree, this is delta 1. So 30 plus delta 1 and that should be equal to how much? 60 degree. It means delta 1 is actually how much? 30 degree. And it is actually in this direction. So I can see this direction is nothing but clockwise. Is this clear? Now, so this, you know, one thing you have to keep in mind. Suppose you have a spherical medium or spherical surface, whatever it is. So whenever you will make a normal, at any portion of spherical surface or spherical medium, that normal will always pass through the center of sphere. Okay. So why I am telling this thing? Because this ray is following like this refracted ray, and this refracted ray actually striking again that surface of this medium, right? Now can anyone tell me this angle will be how much? This is the angle of incident for second case. तो पहले तो आपका यहाँ पे angle of incident हुआ था, refracted ray going and it is again incident on the surface. So this much will be the angle of incident. How much it will be actually? कितना हो जाएगा? कितना हो जाएगा बताओ? पहले तो ये चीज आप लोगों को क्लियर है। सपोज मान लो आपके पास ये आपका
3 डिग्री।
हाँ, सपोज मान लो ये आपका स्फीयर है, एक रे आपका इस तरह से जा रहा है ना, स्ट्राइक हुआ है, फिर रिफ्रैक्टेड होकर इस तरह से जा रहा है ना, फिर इस मीडियम में स्ट्राइक हुआ है। तो यहाँ पे एंगल ऑफ इंसिडेंट कैलकुलेट करने के लिए क्या करना पड़ेगा, कैसे आप नॉर्मल ड्रॉ करोगे? यहाँ पे अगर आप नॉर्मल ड्रॉ करोगे, सपोज मान लो ये आपका सेंटर है ना, तो ये नॉर्मल यहाँ पे एंगल ऑफ इंसिडेंट करने के लिए आपको क्या करना पड़ेगा, नॉर्मल ड्रॉ करना पड़ेगा। एंड दैट नॉर्मल विल ऑलवेज पास थ्रू द सेंटर, दैट यू हैव टू कीप इन माइंड, है ना। तो यहाँ पे एंगल ऑफ इंसिडेंट करने के लिए आपने एक नॉर्मल ड्रॉ की, ये नॉर्मल क्या होगा, इस सेंटर से पास होगा, ठीक है ना, जो स्फीयर का सेंटर है वहां से पास होगा। नाउ वी सी from the center to the surface, this distance is how much? R, radius, right?
R.
So this distance is R. Now I can draw a perpendicular, ठीक है ना, मैं एक perpendicular draw किया था, मान लो this distance is how much? R. This distance is how much from center to this surface? Again R. Is this clear what I'm saying?
Sir.
हाँ, सपोज मान लो सेंटर से मैंने ये जो लाइन जा रहा है वहां पे मैंने एक परपेंडिकुलर ड्रॉ की। अब देखो एक आपका ट्राइंगल ये वाला है और दूसरा आपका ट्राइंगल ये वाला है, ये एंगल आपका कितना है, 30 डिग्री है, ठीक है ना। और ये आपका यहाँ से ये साइड का जो डिस्टेंस है, ये साइड का डिस्टेंस सेम माने, मतलब दो ट्राइंगल का ये साइड सेम है और ये साइड आपका कॉमन है। तो ये एंगल अगर 30 डिग्री है, इट शुड बी 30 डिग्री। चेक करो। हाँ, because sin theta is nothing but perpendicular by hypotenuse. So perpendicular is same for both, hypotenuse is same for both. So theta should be what? Theta should be same. So if this angle is theta, this should be again, sorry, 30, this should be again 30. Now for second case, if I again apply that Snell's law, then what I'll write? That incident जो angle है कितना है? Incident angle कितना है अंजू सेकंड केस में?
30 degrees.
So I can write √3 that refractive index of this medium into sine of 30 degree. That should be equal to how much? Refracted ray जिस मीडियम में जा रहा है उसका इसका मतलब refractive index of AR into sine of R, ठीक है ना। तो यहाँ से आपको मिल जाएगा sine of R. So sine 30 is how much? 1/2. It means √3 by 2. That should be equal to sine of R. It means angle of refraction is how much? Actually 60 degree. ठीक है, एक्चुअली आपका रे इस तरह से जा रहा था, है ना, अगर अनडेविएटेड होता इस तरह से जाता हो, ठीक है ना, और ये एंगल कितना होता आपका 30 डिग्री होता, बट कितना डेविएटेड हो गया, ये वाला पोर्शन डेविएटेड है, एंड दैट इज बेसिकली हाउ मच? दैट इज बेसिकली 30 डिग्री। एंड अगेन इफ यू सी दिस वाज अनडेविएटेड पाथ और डेविएटेड देखो इधर आ गया, सो अनडेविएटेड से डेविएटेड का डायरेक्शन इधर है। अगेन इफ यू सी दैट इज एक्चुअली क्लॉकवाइज, है ना। हमेशा आपको डायरेक्शन करने के लिए अनडेविएटेड पाथ से जो पाथ आपका लाइट ने फॉलो किया है उसको आपको दिखाना पड़ेगा, है ना, मतलब डायरेक्शन देखने के लिए। तो आपका अनडेविएटेड पाथ कौन सा था? दिस शुड बी अनडेविएटेड पाथ, राइट, बिकॉज एंगल ऑफ रिफ्लेक्शन विल बी हाउ मच? 30 डिग्री इफ इट इज अनडेविएटेड। बट कितना डेविएटेड हो गया? 30 डिग्री हो गया। किधर हुआ? अनडेविएटेड से डेविएटेड पाथ का डायरेक्शन। तो डेल्टा 1 वाज कितना था? 30 डिग्री, इट वाज क्लॉकवाइज। डेल्टा 2 30 degree, again it is clockwise. So net will be how much? Delta 1 plus delta 2, and that should be equal to how much? 60 degree clockwise, है ना। तो डायरेक्शन देखने के लिए हमेशा आपका अनडेविएटेड पाथ से डेविएटेड पाथ की तरफ जाना पड़ेगा, ठीक है। एंड दैट E was how much? E, शेखर, कार्तिक बताओ E कितना है? E is actually R. This they have asked to calculate that E also, right? And that is actually 60 degree. Is this clear what I'm saying? कितना क्लियर है बताओ आप लोग?
Yes, sir.
Yes, sir.
Okay. Okay. So another interesting thing about that apparent depth. I think if people are familiar with this, right? And it is basically denoted by d dash. जैसे आपका सपोज मान लो बकेट में पानी रखा हुआ है, उसका जो सरफेस है थोड़ा सा आपको हमेशा ऊपर दिखते हैं, नहीं? Am I correct? जो भी आपका पानी के नीचे होता है अगर उसको देखोगे थोड़ा सा ऊपर दिखते हैं, नहीं?
Yes, sir.
That is because of basically apparent depth, and that is the phenomena of reflection. Suppose you have a two medium and that is separated by interface. Okay, let us assume the refractive index of this medium is n1. Okay, and refractive index of this medium is n2. You are sitting here on the medium 2 and your eye is like this. Okay, a point object is kept in medium on. Okay, here point object O, and its actual depth is actually from the surface. Always you have to keep in mind that you have to measure the depth from where? From the surface. So from the surface to from the point object to surface, the actual depth is actually how much? D. But अब जब देखोगे आपको D नहीं दिखाई देगा, है ना? ठीक है ना? तो आपको क्या दिखाई देगा? Somewhere you will see that object is actually somewhere here, D dash. I am not deriving this part because you know this derivation will take time already because we have to cover many things, right? and सारी चीज आप लोग बोर हो जाओगे. मेरे लिए तो डेरिवेशन करना बहुत इजी है. इट्स अ वेरी सिंपल थिंग, बट आई एम नॉट वेस्टिंग योर टाइम बिकॉज डेरिवेशन में कोई फायदा नहीं है ना. डायरेक्ट प्रॉब्लम करो, ठीक है? इफ यू हैव एनी प्रॉब्लम और एनी इंटरेस्टिंग यू कैन आस्क मी एनी टाइम. इट्स अ वेरी सिंपल थिंग. ओके, सो जो आपका कॉन्सेप्ट है डी डैश बाय डी, मतलब आप जो डेप्थ देखोगे दैट इज डी डैश, और डी क्या है? पॉइंट ऑब्जेक्ट का ओरिजिनल डेप्थ है, एंड दैट विल बी ऑलवेज हाउ मच? ये कितना होता है?
N1/N/2.
नहीं, यहाँ पे जो डी डैश क्या है? अपरेंट डेप्थ जो आप यहाँ से ऑब्जर्व कर रहे हो, है ना? और डी क्या है? इसका एक्चुअल डेप्थ है. डी डैश बाय डी दैट शुड बी इक्वल टू रिफ्रैक्टिव इंडेक्स ऑफ मीडियम जहां पे आपका रे आ रहा है. रिफ्रैक्टिव इंडेक्स ऑफ मीडियम जहां पे आपका रे आ रहा है. तो एक्चुअली आप इस पॉइंट ऑब्जेक्ट को कैसे देख रहे हो कि भाई आपका इस मीडियम से आपका रे जिस मीडियम में आ रहा है, जिस मीडियम में रे आ रहा है, किस मीडियम में आ रहा है? उस मीडियम का रिफ्रैक्टिव इंडेक्स लेना पड़ेगा. तो दैट विल बी एक्चुअली n2. ठीक है, डिवाइड बाय रिफ्रैक्टिव इंडेक्स ऑफ दैट मीडियम जहां से आपका रे आ रहा है. तो कौन सा मीडियम से रे आ रहा है? एक्चुअली इस मीडियम से आपका रे आ रहा है. So you have to take n1. तो वेरी शॉर्टकट में मैंने आपको बता दिया कैसे कैलकुलेट करनी है. तो अपरेंट डेप्थ बाय एक्चुअल डेप्थ शुड बी इक्वल टू हाउ मच? रिफ्रैक्टिव इंडेक्स ऑफ दैट मीडियम जहां पे आपका रे आ रहा है. कौन सा मीडियम में आपका रे आ रहा है? इस मीडियम में. तो इस मीडियम का आपका रिफ्रैक्टिव इंडेक्स लेना पड़ेगा. डिवाइड बाय रिफ्रैक्टिव इंडेक्स ऑफ दैट मीडियम जहां से आपका रे आ रहा है. कौन सा मीडियम से आ रहा है? दिस मीडियम. और इसका रिफ्रैक्टिव इंडेक्स कितना है? n1 है. तो अपरेंट डेप्थ d dash should be equals to actual depth into n2 by n1. n2 क्या है? आपको always keep in mind, you have to keep in mind that n2 is nothing but refractive index of that medium जहां पे आपका रे आ रहा है, और n1 जहां से आ रहा है. Why? Because this is important. I will solve one problem, then you can easily understand why this thing is actually important. ऐसा ऑलवेज नहीं है कि भाई आपको हमेशा कोई पॉइंट ऑब्जेक्ट है हमेशा उसको आपको ऊपर दिखाई देगा. ये हमेशा कोई कंफर्म नहीं है और कोई 100% गारंटी नहीं है कि भाई आपका कोई भी पॉइंट ऑब्जेक्ट नीचे है और उसको हमेशा ऊपर दिखाई देगा. ये कोई 100% गारंटी नहीं है. ये कब गारंटी है? जब आपका ऑब्जेक्ट रियल हो, तभी आपको क्या दिखाई देगा कि पॉइंट ऑब्जेक्ट आपका सरफेस से ऊपर है और कोई डेप्थ उसका जो एक्चुअल डेप्थ उसका जो अपरेंट डेप्थ होगा वो एक्चुअल डेप्थ से कम होगा. बट अगर कोई आपका ऑब्जेक्ट वर्चुअल है तो उसके लिए आपका जो apparent depth है that will be higher than the actual depth. Let us solve a good question. Okay, so suppose this is the interface or surface. यहाँ पे आपका वाटर है, इसका रिफ्रैक्टिव इंडेक्स इज ऑन. सॉरी, ये आपका एयर है, इसका रिफ्रैक्टिव इंडेक्स ऑन है. and in the lower side you have a water, and refractive index is 3/2. ठीक है, और आपका रे इस तरह से आ रहा है, आपका रे इस तरह से आ रहा है, and it is making a point object here at a depth of 60 centimeters. This ray is coming and it is making a point object here at a depth of 60 centimeters. And you are looking this point object. You are looking this point object. So how much depth you will measure? A ray is coming. These are the line of rays. They are coming and they are making a point object here at a depth of 60 centimeters. You are looking this point object. Now, can you please tell me how much depth you will notice? कितना depth आप देखोगे बताओ? राजकुमार बताएगा, बताओ कितना देखोगे? हाँ, तो मेरे को कैलकुलेट क्या करनी है? Apparent depth. So we know apparent depth by actual depth d. That should be equal to how much? Refractive index of that medium जहां पे आपका रे आ रहा है. कहां पे आ रहा है? कौन सा मीडियम में आपका आ रहा है? देखो, एक्चुअली रे आर एक्चुअली कमिंग इन दिस मीडियम, ना कि इस मीडियम में आ रहा है ना? मैंने क्या बोला था? d डैश बाई डी इक्वल टू, पहले आपको लेना पड़ेगा रिफ्रैक्टिव इंडेक्स ऑफ दैट मीडियम जहां पे आपका रे आ रहा है. तो देखो आपका रे एक्चुअली कहां से आ रहा है? इस मीडियम से इस मीडियम में आ रहा है, तो पहले आपको इस मीडियम का रिफ्रैक्टिव इंडेक्स लेना पड़ेगा, दैट इज NW. फिर कहां से आ रहा है? इस मीडियम से, तो आपको इसको लेना पड़ेगा. नाउ यू अंडरस्टूड दिस फॉर्मूला?
90.
हाँ, exactly, it will be 90. Now can you please tell me what type of object it is actually? किस तरह के ऑब्जेक्ट है ये?
Virtual, sir.
Exactly.
Virtual.
So you have to always keep in mind that for virtual object you will get that apparent depth that will be higher than the actual depth. ठीक है, so this thing is actually important for your exam. पहले आपको रिफ्रैक्टिव इंडेक्स उस मीडियम को लेना पड़ेगा जिस मीडियम में आ रहा है, फिर जहां से आ रहा है. ठीक है, okay. Now let us assume, or I'll ask a good question. Can you have to answer? Give that answer. Suppose you have a medium on, noted like that. This is your medium 2, and this is your, again you have a same medium like medium 1. Okay, the refractive index of this medium is N1, of this medium is N2. इसका कितना हो जाएगा? कार्तिक बताओ, this medium का. So this is like identical of this medium, so it will be again N1, right?
N1.
Okay, now I'll make a normal. Now a ray is incident in medium 2 at an angle of I. Then it is refracted. It is refracted, okay, and it is emerging at an angle of E. किस एंगल से emerge हो रहा है? At an angle of E. So basically you have to calculate this angle. You have to calculate this angle. कितना हो जाएगा?
I is equal to angle E.
Exactly. So this angle will be, let us assume this is the angle of reflection. Now if this angle is R, ये कितना हो जाएगा? ये कितना हो जाएगा बताओ?
R.
Minus R.
It will be R. It will be R. You calculate. It will be R. कितना हो जाएगा ये? R हो जाएगा. Just ये आपको इसको बड़ा कर दो, है ना? Now this is you will get two triangles. This triangle and this triangle. Now for this triangle, this is the base, this is the perpendicular, right? This is the base, this is the perpendicular. For this triangle, again, base is same, perpendicular is same. So obviously this angle will be again R. ठीक है ना? ये दोनों triangle से आप बता सकते हो. इस triangle से that this tan theta will be how much? This distance perpendicular divided by base. ठीक है? So for this triangle, tan R will be how much? Perpendicular distance, that is same as this divided by base. This, and this is same as this. So since they have both sides same, so obviously this angle will be same. Now first for this, I'll apply that Snell's law. Then what I can write? That n on sine I, n on sine I, that should be equal to how much? N2 sine of R. Sine of R. So here I have used that Snell's law. Again, I can use that Snell's law here as well, because again your refraction phenomena happen here, right? So for this case, that angle of incident is how much? R. So what I can write, that N2 sine of R, that should be equal to how much? N on into angle of refraction, that is how much? E. That you have to calculate actually. Now from these two equations, since N2 sine R equals to N on sine E, so in this equation I'll substitute this value. So it means N on sine I, that should be equals to N on sine of E. This will be cancelled. We'll get that this angle will be same as angle of. This is clear what I'm saying? कितना clear है आप लोगों को?
Sir, yes, sir.
Yes, sir.
Now
Yes, sir.
I have to solve that. Now we have to discuss about that lens also, because you know maximum question from ray optics you will get from this lens. Okay, so there are various kind of lens. So we have a convex lens. Convex lens. The shape is like this. Okay, and you have a concave lens also. Okay, and shape is like this. Now we'll see. Okay, so this lens, if you notice, then this lens is actually basically made up of two sphere. I mean, if you see this portion or this surface of this lens, it is actually part of a sphere, right? A part of a sphere. Okay. Now, center of curvature of this surface, is nothing but center of original sphere. And let us assume this is T1. ये वाला जो surface आप देख रहे हो, left hand वाला, if I extend, it will make a sphere. The center of this sphere is nothing but the center of curvature of this surface. Okay, and the radius from the pole, you have to calculate. You have to calculate the radius always from where? Radius of curvature always from pole. So from pole to Sion, this distance will be how much? That is the radius of curvature of this surface. This surface, and that is, let us assume this is R1. Similarly, this portion, right वाला जो portion है, ये भी कोई surface sphere का है ना? This is also the part of sphere. Okay. And the center of original sphere, that is the center of curvature of this surface. And let us give that notation C2. Let us give that notation, that is C2. And the radius of the surface of this sphere is nothing but the radius of curvature of this surface. Now if I join these two center of curvature, then this line is basically what, Rajkumar? क्या है ये? So you have a for convex lens, I can clearly see there are two surfaces, and each surface is basically made up of sphere. The center of sphere will be the center of curvature of the surface. Okay, So for each surface you will have center of curvature, and the distance from the pole to the center will be the radius of curvature. So for this surface, center will be C1 and radius of curvature will be this one, and that is R1. For this surface, you have a center of curvature here, okay, and the distance from pole to center, that is radius of curvature R2. Now, if I join the two center of curvature by a line, then this line is actually known as principal axis. Okay, principal axis. Similarly, here also you have a, for concave lens also you can see there are basically two surface. This surface you can see this is a part of a sphere. Okay, so obviously there will be the surface, there will be the center. Okay, let us assume this is C1. Okay, so for this surface C1 will be the center of curvature, and for this surface again I can draw sphere, and it will have center, and let us denote it C2. Okay, now if I join this C1 and C2, again it will be principal axis, and from the distance from pole to C1, that will be R1, and distance from pole for second surface to C2, that will be R2, and this R1 R2 are basically radius of curvature. Okay, is this clear? क्या इतना clear है आप लोगों को?
Sir.
Yes, sir.
Okay, another thing is from this lens that is known as optical center. What is optical center? So for thin lens, the optical center is basically the geometric center of your lens. Suppose this is the convex lens, so the optical center will be the geometrical center, or you can say the middle point of your lens. But the significance of this optical center, so is that whenever rays strike at optical center, the refracted ray will be undeviated. ठीक है ना, चाहे किसी डायरेक्शन से भी आए आपका और वो आपका ऑप्टिकल सेंटर में स्ट्राइक करे ना, if these rays are strike at optical center, irrespective of any direction, that refracted ray will be undeviated, है ना, चाहे किसी डायरेक्शन से आए आपका, अगर ऑप्टिकल सेंटर में स्ट्राइक करेगा, then refracted ray will be what? It will be undeviated, है ना, it will always travel in straight line. ठीक है, and the for thin lens, the optical center will be actually at the middle of your, at the middle point of your lens. ठीक है ना, let us solve a problem, then I'll leave because already you have a time over. But if you see this this kind of problem is really important for your exam, for JAM especially. So they will provide you this kind of convex lens, and for this surface radius is R1. Let us assume for this surface radius is R2, and let us assume that refractive index of this lens is NL, and this lens is surrounded by क्या है? This lens is surrounded by medium, and let us assume the refractive index of this medium is NF. ठीक है ना? Then focal length of this lens can be calculated, and that will be nothing but 1 by f. F is the focal length of this lens. Okay, that will be refractive index of your lens divided by refractive index of medium minus 1 into 1 by R1 minus 1 by R2. Okay, na? But again, you have to use to solve based on this problem, this formula. You have to solve many problems. But for solving problem, especially in optics ray or ray optics, the direction is very important. And I already shared you that incident ray direction, that will always be what? That will be your positive direction. Okay. So you have to keep in mind. Now what is R1? ठीक है, R1 क्या है? ये वाला फॉर्मूला आपको यूज करना है, बट R1 का सिग्निफिकेंस है क्या है? R1 है रेडियस ऑफ कर्वेचर, उस R1 क्या है? रेडियस ऑफ कर्वेचर उस सरफेस का जिस सरफेस में आपका रे पहले स्ट्राइक करेगा। सपोज मान लो आपका रे इधर से आके किधर गिरेगा? पहले इस सरफेस में गिरेगा। तो ऑन बाई जो R लिखते हो पहले वाला R, तो ये R कौन सा है? जिस सरफेस में पहले आपका रे स्ट्राइक करेगा उस सरफेस का जो रेडियस ऑफ कर्वेचर वो आपका ये है ना। फिर आपका क्या करेगा? रे रिफ्लेक्ट होगा। फिर दूसरे बार जिस सरफेस में आपका रे स्ट्राइक करेगा उस सरफेस का जो रेडियस ऑफ कर्वेचर है दैट इज बेसिकली R2, ठीक है ना। सपोज मान लीजिए आपका ए वाला केस में अगर लाइट इस तरह से आता तो फिर आपका यहाँ पे R1 नहीं होता, यहाँ पे क्या हो जाता आपका बेसिकली R2 हो जाता है ना, और यहाँ पे आपका क्या हो जाता? R1 हो जाता, ठीक है। इज इट क्लियर व्हाट आई एम सेइंग? हाँ, सो R1 का मतलब क्या है? NL क्या है? NL है रिफ्रैक्टिव इंडेक्स ऑफ दिस लेंस। NM क्या है? जिस मीडियम में जो लेंस आपका जिस मीडियम में सराउंडेड है उसका रिफ्रैक्टिव इंडेक्स, ठीक है। R1 रे जिस सरफेस में पहले बार स्ट्राइक कर रहा है उसका रेडियस ऑफ कर्वेचर। R2 जिस सरफेस में दूसरे बार आपका स्ट्राइक कर रहा है उसका रेडियस ऑफ कर्वेचर। ये है इसका सिग्निफिकेंस, ठीक है। So based on this, I'll solve many problems because this formula is really important for your exam. Okay, tomorrow I'll solve many problems based on this. ठीक है?
Okay, thank you, sir.
Thank you, sir. Good night, sir.
Good night, sir.